Wow. Nice! Whoa! Let's get to the video.
Hey everybody, how's it going? Today I have a Minn Kota V1 setup. Got the foot pedal and the circuit board that goes with it. Some of it works and some of it don't. To start out, I already replaced the circuit board in here because some of the buttons were not working correctly, not working all the time, and the board had some damage done to it. So we got that out of the way. So that still didn't fix the problem of spinning the main motor. So we need to look into it a little bit deeper. This is just a cobbled mess right now, but it's simple. I got my power supply lines coming in right here, 12 volts off my power supply. I got each meter hooked up. This one is hooked up to the main motor that spins the propeller. This meter is hooked up to the other motor that turns the motor right or left. So, and that's all we need. And then we got our little battery powered board, how much battery power is left on your battery. So this is what's going on. I got the power on now. This doesn't show them all because it's on a power supply. So what I'm gonna do is just go through these switches and show you what goes on. So this is the power button. I turn that on and I can hear the relay clicking when I turn that on. Okay, so this is the power button to actually spin the big motor. That's going to be on this meter. I released, pressing, and you can see we're not getting any voltage out of these two lines right here where the main motor connects to. So we're not getting an output on the board. So this one here, the foot pedal is turn the motor right and left, is on this one. So if I push it down on this side, you can see it's 12 volts. If I push it down on this side, you can see it's negative 12 volts, but 12 volts. So, and this slider right here doesn't do anything. That doesn't read anything because the main motor's not spinning. It's not getting an output. So this won't work at all. So that's our problem. And what I'm gonna attempt to do is we're gonna try to get the circuit board out of this blob of mess. You can see, let me disconnect this. When they made this circuit board to make it waterproof, they just surrounded the whole thing with probably some kind of RTV probably or something. It's really hard though. So I'm gonna attempt to take this off, take it apart, and see if I can get to the board level and find out what's going wrong with this. Because our relay clicks, so it's turning on, but we're not getting an output. We'll have to check these. There's three diodes, I think, right here. But we can't check those because we can't get to anything. We can't check anything. We're dead in the water here. I got two capacitors I noticed that are a little damaged. This one here, it looks like something hit it, so the corner of it is smashed in. So I don't know if that ruined that capacitor. And this one's about the same way. It's got a little dent in the corner. So who knows if those may be causing the problem. I see the top of a transistor right there. But yeah, that's about it. Yeah, it's gonna be a chore, but I don't even know if it's possible, but we're gonna give it a try. So let's get at it. Well, there's the back side of the board. That stuff is pretty tough getting off there. A metal screwdriver is not the best thing because you scratch the board all up and everything. Luckily I didn't scratch it up, didn't ruin any traces, didn't ruin anything. And yeah, I tried that stick and my stick and it broke. But yeah, I guess I need a plastic one or something, a little bit more durable than a stick. So we have our transistors, I said right here. Actually, we have two of these are MOSFETs, and this is a diode, a dual diode. And I checked those and they're not shorted. So I don't know if they're any good yet because I haven't checked them that way yet, but it would be best, I think, to take them out of the circuit. But we only have the back done, so it'll be a little bit more work trying to take them out. I gotta clean up the front. And at least we can kind of tell what kind of stuff is on the circuit board. We got a big chip right here. It's probably a processor or something. But yeah, doing the other side is probably not gonna turn out very good because breaking off components or something like that. But I'll So I've went a long way since I started peeling off all that stuff. You can see it's all right here. It's a big mess. But here's all the components. This empty circuit board. So everything is, in my mind, pretty much junk, and I wouldn't put it back on because taking all this stuff off, I'll show you some pictures over here. You can see what it looked like when I was taking it all off and what it looked like when it was cleared the best I could get it. But yeah, the components are good, except for this one diode, glass diode, that I broke in half, and I have no clue what it is. That's the only one that I can't figure out. Everything else, like I said, was good for the most part, and I think I figured them out. It was kind of hard to read on these glass diodes what the values were for them, but I believe they're just small signal diodes. This diode that I broke, it could be a Zener diode. Did a quick sketch. This is what it looks like on the circuit board. D3 is the diode that's broke, and you can see the way that it's connected, that this side goes, the anode side goes to ground, and the other side goes through this resistor, and this is the VCC connection of our main chip, our big chip that's on there, which at the moment I can't think what it is, but I'll put it up there. But yeah, and then these are just a transistor that's connected. So it's a protection diode, so it could be a Zener diode, but our chip that's here has protection on the inside of it. It's got a regulator that protects it because it goes from like 8 volts to 40 volts. So you really don't need a Zener diode, but they might have did it just for extra protection, in case maybe they connect the positive and negative backwards or something. Who knows? But yeah, that's kind of what that looks like. I was gonna say, oh, the other side of this piece of paper is I drew out the whole board and all the placement of all the components before I took them out of the board, so I know what the values are for each thing and where it goes, just enough to keep a record of it. Except this part over here, I think that's something else. But yeah, just a reminder for that. But I did come across this part right here. This is a dual op amp, and I suspect this being the whole culprit right here. I'm gonna have another video up. I don't know if it's gonna be before this one or after that one. After this one, I had some weird things happening. This chip, when I measured across one of the outputs and the input, the voltage input, it was shorted and it beeped on my meter. This whole setup has been sitting around for quite a long time, probably I would say a month. And when I got all this stuff right here, which are all the new components, I bought some new op amps and I compared it to this one here, and it all about reads the same. And that continuity test between those two pins didn't happen anymore. So it's like it healed itself. I have no idea. And yeah, so what do you think about electronics healing themselves? I'm gonna assume it's still bad. I'll do a comparison here so you can see and I can see, and I don't know. That's a weird subject right there, things fixing themselves. But on the circuit board, you can see all the gold spots, the shiny spots. That's where my screwdriver dug in to the board, because it was really hard to get all that stuff off there and try to do it without breaking the components. This is where the relay was, and I was trying to get underneath that to help pop it up. And you've probably seen in the video that of me tearing this apart that I used an awful lot of heat right here with the heat gun to get this relay out there, and I actually warped the board right there. And you see me with the screwdriver pressing down on it as I heat it up. I was trying to straighten that back out, and it worked. It looks pretty straight now. So, but yeah, you can see this is what the board looks like with nothing in it, but you can see the components, locations, and everything. And this is the back. So it looks like regular circuit board now. So the only another boo-boo I did was this one right here. This pad disappeared when I was trying to take these wires out right here. There was 6 wires in there, and I was trying to take it out, and that pad disappeared somewhere, but it goes through on the other side. This pad fell off too, and it actually broke away from the trace. I just soldered that together just to hold it there for now. I'm going to use some nail polish or nail gel and UV cure it, so it helps hold that in place when I solder the wire back in there. So yeah, that's just one of those things that happens when you're trying to do this stuff. Yeah, we got a couple big jumpers here. Our transistor. This, I can't remember what this was. This is a tip 42 transistor. We have our dual diode, our MOSFETs, all our resistors, regular resistors. We have 0 ohm resistors right here. We have blue resistors, which are our 1%ers. Little round capacitors here, regular capacitors here. This is where our cables, our power, and input and outputs are connected to. And they have these little rubber things, so it covers it. I'm gonna have to get some new ones there because these got damaged. All of this is just tubing, so that's all right. But yeah, that's it for that. And so now I'm gonna go ahead and start repopulating this board. And for D3, the diode I broke, I think I'm just going to, and you'll be there with me when I do this. I'm gonna not populate that, and I'm going to fire this up. Hopefully everything works, and we'll measure the voltage across there and see what kind of a Zener diode to put in there. That's what I'm guessing what it is. If you see this video and you have a different opinion, sure, go ahead, throw it down on the comments. But yeah, all right, I think that's enough blabbing. So let me get populating this board and see if we can get this thing turned on. All right, so I thought we'd go just quickly check through these chips to show you what's going on, what's the difference between them. I have a new chip here, I have the old chip here. Remember I was saying just a few minutes ago that I touched the output and the voltage input and I had continuity. Well, I don't anymore. Okay. This one is the output or the input, so I can touch any pin now. And I have no continuity. but when I touched these two, I believe it was these two, number one is the output, one of the outputs, it had continuity. Every time I touched it, it had continuity. And now you can see it doesn't. So, do electronics really repair themselves? That's up for debate, I guess. They're working on stuff, so these days it probably does. But I don't know, these chips, I don't know if they will or not. But anyway, let's get back into diode mode here. And this is our ground, our number 4. And we'll compare our old one to our new one to see how much difference we have. So this is pin 1. If I can get it on there. 0.74. The new one, 0.75. Pin 2, 0.8. Pin 2, 0.74. Pin 3, 0.8. Pin 3, 0.75. Okay, so there's some difference there, but just by a little bit. But all right, so we'll go pin 5, 0.8. Pin 5 on the new one, 0.75. Pin 6, 0.8. Pin 6 on the new one, 0.74. 7.74. Pin 7.75. And pin 8.64. Pin 8 on here, 0.68. So they're really close now. And this I considered to be the bad component. What do I do now? Is this, if I put all these components back in there, will it work? Well, please remember that, because I have a stereo receiver video coming, and I'm going to talk more about that. All right, so let me pop these out real quick. I had tape holding that old one in because it just wouldn't stay in there. Let's see what these do. I'll put the name of what this is up here so I don't have to try to remember it. I'm putting that down there so the tape can hold it because the legs are a little deformed. And I'll put this one in here. And that one will stay. So hopefully we'll be able to test it right now. Alright, so let's do the same thing. The ground pin. Which one was that? Back in 1 second. That was easy. I could have remembered that. Pin 8. Pin 15 is the input. Voltage input. Alright, so 8. Let's start with the old. Pin 1. 1.4. 1.38. Pin 2. Nothing. Pin 2. Nothing. Pin 3. 1.37. 1.35. 4 is nothing. 4 is nothing. 5, nothing. 5 is nothing. 6, nothing. 6, nothing. 7 is nothing. 7 is nothing. So far, good, right? Well, I have to do this one over again because I don't know if you caught it or not, but I was using the negative on the ground, and you should be using the positive so you get the right voltage readings. And then I watched that video of me redoing that, and I could not stop laughing because I started down here, started checking here, going down this way like this on both of them, but when I got about halfway, a little over halfway, I started going back up and never even checked the rest of these pins. I just died laughing. It was so funny. I wasn't even paying attention. So let's try this for a third time and see if I can do it right. We'll start from the top and go down this way. Okay, so here's our ground. We go pin 1. We have nothing. Pin 1, nothing. Pin 2, nothing. Nothing. Pin 3, 1.09. 1.09. Pin 4, 1.08. 1.09. Pin 5, 0.76. 0.77. 0.73. 0.73. 0.63. And 0.63. I think we did that side right. So let's start with this side now. 0.63. 0.63. 0.72. 0.72. 1.96. 1.99. 0.65. 0.65. I think I did this one. 0.6. 0.6, yes. 2.0. 2.0. 0.62. 0.62. 0.59. 0.6. All right, I think we got through it right. I can't be 100% sure since I can't get my mind working right for some reason, but there we go. Now we can go back to the other video, but that was the end of that video anyway, or that little section of the video. And I do remember saying that I bought this also. I forgot to show you this earlier. This is electronics grade gunk to fill our board back up with goop so we can waterproof it. I can't get that to, there you go, kind of. I don't know why that doesn't focus on there. Anyway, that's what we're going to use once we get this board all working right. If we do, this stuff is freaking me out. All these weird things going on. It's getting ready to start soldering this stuff in, but I figured since we checked the 2 ICs, why not take a look at our MOSFETs and our dual diode and see what the difference are compared to the old and the new. So I have the 2 MOSFETs right here. Let's check and see what that says. So it's 0.65, and then I'll touch it over there for 1 second and then come back and touch it again. Now it reads 0.016, something like that. Okay. Let's do the other old one. 3.97. Go over there and touch that. Come back. Now it's 0.018. Okay, so we have some pretty low ones there. 0.02 now. So if we go back over here and touch that and then come back over, it don't do nothing until we short them together. Put your finger on there. And now we test it again. We got 0.558. Go over there and touch that one. Come back here and touch this one. Now we got 0.015, something like that. Okay. So let's see what the new ones read. So this reads 0.5. We'll touch that one over there, and then we'll come back here. This reads 0.075 and climbing. So that's kind of a big difference. This one here is 0.539. Touch that one over there, come back. 0.075. So yeah. So if we touch those, drain that out, we can test it again. 0.562. 0.07. So we got 0.07 compared to 0.023 on that one. 0.023. So there's a little bit of a difference between those. And you know, it's probably because these are being used. But so let's look at this dual diode here. Measure this one. 0.235 on that side, 0.232 on that side. That's the old one. Now the new one is 0.187. The other side, 0.186. So yeah, that's a big difference from 0.234. 0.232. So yeah, there we go. Just thought I would throw that in there. We could look at the transistor, see what that says, huh? If I can get a touch rate. 0.679, 0.684, stay still for me. 0.68988 and 0.688. So that's the same on both of those. So the new one is really close, 0.678. It's like 10 off. 0.68 there. Yeah, so that they're almost about the same. All right, yeah, just wanted to throw that in there. Let's get at populating this board. All right, we have the whole board populated. didn't go too bad. So I got it all set up now to where we have our power coming in. That's going to be read by this meter right here. It should just read 12 volts, and that's connected here, negative and positive. And then I have this meter that's going to check the location of where the diode is that I broke, going to the negative and the positive sides of that. And that also is where it charges or powers the chip. So we should see some kind of voltage on here, and then we can decide what kind of Zener diode to put there, or figure out what kind of diode was there. So without further ado, let's give it some power and see what it does. Hopefully it doesn't blow up in my face. Alright, power on. Alright, we got our 12 volts here. We just have millivolts here right now. .47 millivolts. So there isn't a whole lot going on there right now. Let's see if the chip has voltage going to pin 15, because if I remember correctly, that is the power. Yeah, so it's just still some millivolts there. There's nothing coming in there. Let's see what we have on our output. I didn't hear it click, so that's one thing, and it's probably going to need the foot pedal for this. Was not getting any voltage out here. Yeah, so we're not getting anything. I'm going to grab the foot switch and connect that up, and alright, let's turn it back on. Didn't hear no click at all. I'm going to turn the switch on the foot switch. There's the click. That's the click we're looking for. But we're still not getting really, oh no. It would help if I hook this up, wouldn't it? There we go. Now we're getting 6.6 volts across the diode that I broke. So that gives us an idea on what should go there. Let's take this and see if we have an output. Remember, we didn't have the output. This is our negative. This is our positive. Hey, and look at that. We have an output now. If I can keep my probes on there. There we go. 12 volt output. It is working. Working the way it should. Let's see if we, let's see, let's turn this off. And I'm pushing the foot switch now. And you can see it went to 1116. I can't, I'm gonna have to do this. See if I can get those rested in there. To make a connection. While I push the switch. Get this over here, out of the way. See if we can shock myself or something. Alright, so I have it up to You still can't see that. I have it up to 4. I'm going to push this button. It's 12. That's all the way off. 12.55. Let's go up. And you can see it doesn't vary it that much, does it? It clicked off because my hand slipped off there. But it's down to a little under 11 volts. Doesn't make a real big difference, but we do have some power now. We'll turn that on. We should get 12 volts. Turn it this way, it would turn the motor. Turn it this way, it would turn the motor. Now what I'm going to do is I'm actually going to talk to the guy, and I'm going to see if I can get his trolling motor over here and hook it up, because he told me that he took it off his boat because I let him know that I didn't know when I was going to get this done. So it's been a couple months, but yeah, since now we're getting our output, I want to put a load on the board, so hooking it up to the motor will definitely have some load. We'll have some current going through all these new parts, and we'll see if anything gets too hot, blows. It shouldn't, because everything is exactly like brand new now. I don't know what the total price is for everything. I haven't sat down and calculated that out, but it's way less than buying a new board. Probably, I am positive. It's just if you have the know-how and the time to do what I did, then you could fix this yourself, or bring it to somebody that is willing to do it. I'm usually willing to do everything, but so yeah, I'm going to this is a go. This works. Taking all this time to do this, it works. So I'm gonna go and get his motor, and it'll probably be a few days, and then I will record what happens when we connect the motor up to make sure that everything does what it's supposed to do. And I will throw in a diode in there. All right, I got this all set up here. Kind of just temporary, but I got my meter hooked up here, and I have that connected to the 6.8 volt Zener diode that I put in there. So just so we can see what the measurement is. Hopefully you can see it from that far away. But I got my battery back here. Nothing's in the way here. We got our little remote. I'll just start by turning it on. And you can see it start to spin. And we got about 6.53 volts on there. Now I can move our varistor up and down. That's all the way up. That's still about 6.5. Went down a little bit. So that works good. Then we can turn it. And then we'll turn that back off. And now we'll push the button that you can step on it and have it set to a variable speed. So everything looks good.
Yes, sir. Come on, little buddy. Day is a oyster.
In this, so far I've noticed this voltage stays around 6.5 volts, so I think a 6.8 Zener diode works out perfect for that. So that's what we'll leave in there. I've let this run for quite a while already, but I'll let it run longer, just get it a good break in, and see how everything works. And it should work fine, no problems at all. Next thing we're going to do is we're going to take the board and we're going to pot it. I'm going to make a little square box about as big as the board, because it has to fit right down in here, so it has to be a certain dimension to fit down in there and screw down to the aluminum bracket. So I'll just make a temporary little box and then put the potting material in there, set the board on top of it, throw the potting material over the top of that, and we'll see that next coming up. Well, I think it's time to pull the circuit board out of the gook. You can see it's all nice and party and shiny. Feels nice and rubbery. It dried clear, so that's cool. But yeah, let's see if we can get it out of here and see if it is completely dry. It's been sitting for 2 weeks because of how thick some of it is in here. So I gave it extra time to dry, but you know, it's not getting no air this way, so I'm afraid to see what the back looks like. But yeah, we'll tear into it and see what we get. Pop this screw out of here. Hopefully it's geared all the way through. Just want to peel this off there. That was just to keep the screw area open so we can get the screw in there afterwards. Yeah, just like that. And then let's see about cutting this off. I don't know if this is going to work. Oh, that wasn't too bad. That was a little tough. Definitely need to get some bubbles out. Should have put it in a vacuum container. You can see all the little bubbles down on the bottom. I have a vacuum pump too, so I should have done that. I'm getting a knife to make it a little bit easier to come away from the edge. I'm just going to cut this down. That way that'll come off easier and not break away the silicone. I'm sure we're going to have to touch up some of the silicone after pulling this out of there, which is fine. I was expecting that, especially with the bubbles that I couldn't see from underneath, because we do want it waterproof. That's about all I can get. Tough. You can see it sticking to the plastic pretty good. Guess that concoction that I put on there didn't work very good, huh? It was just something I was going to try. Yeah, it's actually pulling away from the board, so yeah, we'll have to touch up the back side. Yep. We'll probably have to give the whole back side a good coat. It's still actually wet a little bit, so yeah, I wasn't getting any air in there at all to dry that. Even after 2 weeks. Wow. That looks pretty nasty. Guess we can let this dry and then add some more to it. It did, oh, I guess it is a little damp still on the circuit board. It's still covering the circuit board, but there was just a big air bowl in there. Before I put this all in the motor, just wanted to show you a little bit that I did fill that in. I didn't cut any of that off though. It isn't going to hurt anything, so I'm not going to mess with it. But you can see what it looks like when it dries, pretty much like the front. And the more I got looking at this here, the concoction that I made, I think if I would have put a little bit more in there and this would have dried completely, I think it would have worked just fine. Because this is pretty smooth. It looked pretty nice. But because this wasn't dried, that's why it pulled out. I think if it was dry, it would have pulled off just like this, and we would have had this nice finish on there. But yeah, it's all sealed up. Unfortunately, it didn't turn out as perfect as I would have liked it to, but yeah, let's go throw this baby in there. All right, here it is. Got it all put back together again. Got the new board in there. I put some heat sink compound on the big heat sink that's on there before I put that in there. Everything's hooked up. Got my big bucket of water here so it can put some current on that board. Just make sure everything's all right, which I think it should be. I haven't turned it on yet, so hopefully my water thing don't fall over. It's kind of sitting up here generically. Let's turn it on and see what happens. Oh, it's working so far. I don't have it up very high because the water will start shooting out of here. So I'll put this over here. I thought maybe that'd help a little bit. This will let that board draw some more current because of the weight of the water hitting, the propeller hitting the water. It's going to make it tougher to spin, so puts more current through there. It's going to heat up that board, just like it was, out on the lake somewhere. Yeah, you can't pull it up full blast or anything because this container isn't big enough, and there's only like an inch on each side of the propeller in there. So, yeah. But we'll try to let it run like this for a little bit, just to make sure everything's cool. But otherwise, yeah, I think that's a done deal.
Whew, you don't say. Well, I'll be about time. Come on, little buddy, we got work to do. Nothing like a fresh start and a hungry trout.
Show's over, folks. We got fish to catch.